Some of those themes came up a little bit earlier in the discussion on the panel is how do we take what we're doing and we push it out to end users who have to be able to interpret what it is that we're doing. So I'm gonna try to keep this as a half hour. So there's only so much depth that we can go into in that amount of time. So I do want to make sure I have a little bit of time for questions. So if I seem like I'm going really fast, that might be why. So I'm going to start, and I'm going to say that this is a four-step process. So the first piece is determine who your end user is. Who is going to use the analytics? The second step, once you know who's going to use the analytics, is to build a team of the right analytics talent. Talk about what that means. Next piece is to develop the analytics collaboratively. You can't do an ivory tower approach when you're talking about building analytics for somebody in the field who needs to use them. And then finally, you have to tell a story with the data. So I'll go through the 4 topics here. Am I good? All right, let me see if we can do. There we go. All right. So this is not the right version. There we go. All right. So there you go. Any questions? Oh, sorry. All right. All right. So who's the end user going to be? One of the important distinctions that I've seen in the data science space is: are you building analytics for computers, or are you building analytics for humans? Who is the consumer going to be when you're building a new recommendation engine or you're building something for web analytics? To implement the model, it's not quite as simple as copy-pasting some code and putting it out there, but going into production is an extremely straightforward process. And once you put that model into production code, then the model is running and it's being executed on 100% of the time. When you're building a model for human users, you have to productionalize the code and actually have it be out there generating the analytics and pushing out the views, but you then need to be able to take what it is that you're seeing there and have a human interpret and use it. And until they're doing that, you're not actually executing on the model. You're just doing math for fun. And math is fun, but it's not a good business case. So finding the right analytics talent is key. And finding the right analytics talent takes a lot of time and effort to figure out what that is for your business. But one of the things that I see that's really important is, so this is, I think there's lots of different pathways that we've all taken to come to this data science space. But one of the kind of traditional views that I've seen that really helped shape my thoughts on the talent in this space is really that convergence between the computer science end of the spectrum and then the research and mathematics end of the spectrum. And as kind of those two have converged, you see this new field of data science, which is really the blending of those. This is really helpful in terms of when you're looking at building a team, what are the types of talent, what are the things that I need, but it's missing a component. The talent has to be tailored to your organization. And if all you're solving for is the math skills and the tech skills, you're missing the most important thing, which is the business aspect of it. You can't hire people just straight from academia and expect them to be fully amazing contributing members of your organization. And I don't mean the analytics team. I assume that you're going to hire great people that are going to be contributing to the analytics team. But your ability to actually effectively build those analytics requires the people on your team to understand the business context. You can't necessarily bring them in right off the bat, but one of the things that is important to look for when you're doing advanced analytics for business users, whether or not they necessarily know your domain, you should be looking for analytics people who have experience in building analytics for human users, right? So if you're in a business context and you're pushing out algorithms for the first time to a business audience, hiring the unicorn, the guy who's got the PhD from Stanford and worked at Amazon and has built recommendation engines out the wazoo and does all this crazy math, that's not necessarily the talent that you want to find. You don't have to get the unicorn. You don't need to have that person who has the perfect data science resume. You need somebody who's built models that people have used. Whether the techniques that they've used have all been very, very simple, chances are that's all that your end user is going to be prepared to use, especially early on. And you can progress over time to building out more advanced analytics, both more in quantity and in kind of depth of analytics sophistication, but you have to build to that. You can't start from your endpoint where you have tons of really, really cool and new analytics out there. But it's So having a great analytics team is I should also say that's a team. So finding, if you're a small organization and you only get to hire one person, it's pretty challenging to do. But you shouldn't be viewing every person as the Swiss Army knife that can do all of the things. You should be bringing in a team that solves for the different aspects of this. So you can have people who maybe are a little less sophisticated on the data side, but are more sophisticated on the business side of things. And you need to bring those, you have to have all those skills in-house, but it doesn't have to be all in one person and every person knows all of it. But building the team isn't enough. Just having a great team in-house, like it says right there, are organizations that think differently about analytics. And again, I'm not thinking about the organization as a whole. You may have a C-level executive or a CEO or a C-suite that really believes in analytics and is really pushing for it. But having that high-level support, important. Having a great analytics team, also important. But if you don't have a culture, a data-driven culture within the company, all of your efforts are going to be for naught. So, a couple of random quotes here, right? Like, what is the viewpoint of the end user, right? If you bring me the data, that's all I need and I'm going to go on it? Or do they view, like, all of this statistics as just, like, hand-waving BS? Because, trust me, there are end users out there that is their viewpoint. They don't believe the statistics, and they don't want to use them because they have 20, 30, 40 years of business heuristics knowledge. And when we come to them and we say, here, I know you've been doing this for 3 decades, but I'm smarter than you are. Here's your numbers. That's how it comes across if we're not bringing them into the process the right way, and they're not actively looking to use what it is that we're taking to them. So the next piece, once you've kind of built that team and you have an organization or you're working on the collaboration with the organization, once you start building the models themselves, you need to be very collaborative in that process. So the team from HCA this morning was talking about doing the agile sprints where they're pushing a new piece every couple of weeks. They are, from an end user perspective, that's very hard for them to do. Plus they're a vendor, right? So that's really hard to do when you're pushing it out there to get that buy-in from that end user. You need to bring them into the process and have them be part of the sausage making, such as it were. And there's lots of different methodologies that people use, right? Whether you're talking about you use the SEMA model, you use CRISP-DM, you use your own method. You should have a standardized methodology that you're doing to build the models, but you need to explicitly bring in the perspective of those end users while you're building the models. It can't be, what's your problem? Okay, we're going to go off and solve it. Here you go. Because getting that buy-in is really important, and it's much easier to do that along the way. It's hard to do it effectively either way, but so, here's kind of an illustrative process. I think it's a fairly standard one around how you build the models. And all throughout this, there are examples of where you need to be bringing in the user to figure out the right things that you're building out for them. So, as you're choosing what projects to work on and you're prioritizing it, you need to be asking the business, what is the problem that you're trying to solve? It's very easy for us to sit back with the data and say, hey, I see this in the data. This is really cool. I'm going to build a model to predict X. Well, if nobody on the other side of the fence is asking for help on X, then it doesn't matter how good the model is. They're not actively looking to do it. So what you need to find is, what are the use cases that they are trying to solve? What are the problems they have? And solve their problems, even if you don't think that they're the most important ones. As you develop your plan, structure the analytics approach. What type of model am I going to build? What is, once you've identified the use case, what are you going to do? You need to define the problem. I realize I said you just asked the business, what is the problem you're trying to solve? As we all know, a lot of times they come to you and they say, help me be more profitable. Well, what's the problem, right? We need to be more profitable. Right? So we have to help them actually define what is the problem that we're trying to solve. They'll probably have like a very big picture question. They don't necessarily know how, from an analytics perspective, we can help. So narrowing down that problem and focusing it on the right aspects of it, where you know that the advanced analytics, the data science can actually help, you really have to be very, very crisp on that. This is both from an effective project management perspective. You need to be clear, and here's the scope, right? I need to be able to be clear on, here's the scope, here's the deliverables, here's what we're all working together to get towards, and you need to be really, really clear about that up front. Because if you're not, you're going to have project management scope issues, you're also going to have buy-in issues again, right? If you're promising the world, or if you're not clear about what you're promising, they're expecting the world. The solution design. So this is the part of the process where this is very much on us. This is the heads down modeling phase. This is when you're bringing in the data, you're cleansing it, you're structuring it, you're starting to run algorithms, you're starting to see what are the predictors, what am I seeing in there. It's actually really helpful to bring them along for that. It's something that they don't necessarily understand all of what you're trying to do, but it's easier for them to understand the end output if they've seen along the way what you're trying to solve. One of the things I think is really helpful in this process is we know a massive amount of the work up front is doing the data prep, data cleansing, data structuring. When they actually see that, and more to the point, if you have bad data quality, which a lot of businesses do, if they are actually seeing the effects of the data quality on the end results of the models, that spurs them to, hopefully, that spurs them to help be invested in getting better data quality because they actually understand the impact of it. Implementation. Implementation, as you're going through that process, you need to be very, very iterative with the end users to make sure that what it is that you're pushing out, both from an algorithm, the reports or the dashboards, however you're doing that, that needs to be very frequent and iterative as you're testing what that final implementation is going to look like. Again, this is just good project management methodology, but also very important to make sure that they actually understand, right? That here's what the model says, here's the output. Do you understand? Do you have any questions? Where are you going? Does this work? How does that? So the iterations, again, the collaboration and the iteration is very important. And finally, once stuff is out live in the world, you have to have a feedback loop in place. And it doesn't mean, hey guys, here's the training session, here's your new model, here's the email that you can email us if you have any questions, thanks, bye, right? That's not going to be sufficient. You need to put something in place where you actually get the feedback because because things happen. Stuff goes to production and it doesn't do what we expected it to do all the time. I won't say ever, but it definitely doesn't do it all the time. So you need to be able to hear from them when it's not working because if something's not working out in production and you aren't soliciting that feedback, then they're just going to lose faith in the model and they're not going to use it because something's not working. If you're not asking them repeatedly, right? This is on us to pull that information because if we're not pulling what's not working, they're just going to complain about it off to the side. They're not going to come to us to say, hey, your stuff's not working. You also need to talk to them, what are the trade-offs in modeling? So for those of you who saw the panel yesterday afternoon around the future is now, one of the things that I thought was great was the repeated push of linear regression is the best model to build coming out of the gate, right? And I don't remember, it might have been Monica toward the end, was talking about, look, in a lot of businesses, nobody's using sophisticated analytics. So coming out the gate for an end user who's never used analytics and they've done everything based off of judgment or heuristics in the past, giving them a deep learning model right off the bat, that might be the best, the most accurate model you can build. Or an ensemble, right? I mean, ensembles are great. So productionalizing ensembles is not great. But again, right, so accuracy is what we tend to focus on because that, as statisticians, as data scientists, that's what we're like kind of bred and trained to focus on. But that might not be the most important thing, right? The ability to get it out quickly, the ability for them to actually digest what you're giving. If you're on the fence between are we going to use 5 variables or 6 variables or 20 variables or 100 variables, you're going to have diminishing returns on those variables. What is the trade-off, right? How much lift am I willing to give up to make it easier for somebody to understand the output of it? And again, this is then part of that iteration, not just the first time, and that analysis never stops. We're going to go back and we're going to tweak the model and we're going to build it and we're going to hopefully, right? You never put something out and just let it go forever. So as we're going and as we're iterating, the first time you might say we're going to err on the side of simplicity. One, it's quicker, it gets it out to people, and then the next time, hey, what's the next couple of variables we should put in this? Or here, maybe I just did a very simple decision tree the first time. Now let's try a random forest. Or let's try a GBM. Let's do more advanced processes as we go along that when we have people who've bought into the model the first time, then we're going to have that continued buy-in as we build the accuracy of the models over time. Doing it right out of the gate, though, is very, very challenging. But you have to be very clear with the end user about this, right? They're not all mutually exclusive, but you have to be able to say, hey guys, I can build you something that's a little more accurate, or we can build something that's a little easier for you to understand. What do you think the right thing to do is here? And there, and this is part of that iteration. So as you're building and you're in the modeling phase, you can build, hopefully, depending on the speed of your team and the tools you're using, and if you're using stuff like H2O that does a lot of that kind of manual grunt work of doing the statistics for you, you can build, here, I'm just going to run a GLM, and I'm going to run a 5 parameter, a 6 parameter, a 10 parameter, a 20 parameter, and take all of those to the end users and say, hey guys, here's the effect of putting this 6th variable or this 10th variable in here. It's going to make a better model, but does that make sense? Do you understand it? Do you know how to use it? You don't have to you shouldn't cede the decision to them, but you need to have a discussion. It shouldn't be a one-sided decision in either case. All right, so finally, you've built your model. Now you're ready to go, and you're going to take that model out. You're going to push it out to the world. How you do that, and telling a story with the data is extraordinarily important. I actually just read an article recently that said one of the best places to look for data storytellers is like marketing and sales people who are sophisticated enough to understand what you're doing. They don't have to be data scientists, but actually actively looking for those skills, people who know how to tell a story and are data savvy enough. That's a really important thing to bring. It's a very important aspect of an aspect of building your team is people who know how to tell stories. Sometimes it's easier to find somebody who can tell a story and teach them about data than somebody who knows data and teach them how to tell a story. But there's more than one way to tell a story, right? So a little bit of a dig on myself, right? So data science it's not about cool graphics and visualizations. That's a fun part of what we get to do, but the aim isn't, I'm going to build the coolest visualization so that I can go publish something or have a paper out there. You need to be telling a story tailored to your end user. So a couple examples, right? So if you go to Google and you type in weather, this pops up, right? This was the weather, whatever day I pulled this for my hometown, right? This is all you need to know if you're the average Joe just trying to figure out, hey, do I need to take an umbrella today? That's all you need. This is a skew-T diagram, which is a meteorological output. It's an upper air sounding, taken same time frame. This tells a weather forecaster everything they need to know about the weather for the next 24 hours. The data in the middle has temperature, it has humidity soundings, it has the wind speed, it has the pressures, you can see inversions, which is how the air is rising and falling and cooling. Along the right, there are indices coming out of over a dozen models. As a forecaster, when I was working as a weather forecaster, this told me everything I needed to know about the next 24 hours. But there's a reason this doesn't come up when you type in weather on Google, because it also took me a week to learn how to even sort of read this. And it's been long enough now, every time I look at it, I have to, which one are the dry adiabatic lines, right? There's tons of information there for a very sophisticated user. But we're telling the same story, right? These are both telling me what the weather is going to be. You have to tailor it to that end user, though. You have to tailor it to the audience, right? So know who your audience is, know who the consumer is, and make those visualizations appropriate for them. Some tips for effective storytelling. You don't have to explain how the model works. A lot of times that's what they'll ask for. Well, we need transparency. I need to understand how the model works. I need to understand the algorithm. That's them trying to understand how to use it. They don't need to understand what the model's doing. They need to understand how to use the output of the model. As a forecaster, my job was not to go in and look at the model underpinning and look at the math and see what the output was. That wasn't my job. My job was to take what it was telling me and apply it to figure out where was the model right, where is the model wrong. Again, iterate frequently. I can't stress that enough. Iterate frequently. This is something we absolutely do. This is science. This is research. We're trying stuff. Iterate with them. Don't exclude them from this process as you're building the analytics. Bring them into it. Make sure that they understand, hey, this is a little bit messy, but But getting that buy-in from them and this also helps finding false starts early on, right? You can build a model. Great example, we were building a model on pricing. And my team finished their algorithm, took it out, had already started building the production code, and one of the end users who they were talking to said, like those two variables aren't available until after we've bound the account, right? So they are great predictors. They're just not available when you're trying to price. So that's something that we could have found out 6 months earlier if they were part of the process when we find it. So again, right, like all of this, this experience I have, all of this is usually because we've screwed up, and it's iterating frequently helps you. I don't like the term fail faster, but it definitely helps you understand where you're gonna fail a lot more quickly. Tailor the message and the visualization of the audience, right? That is extraordinarily important. Acknowledge the presence of outliers. This is something that I feel like some statisticians, they don't like to talk about where the data is weird. They don't like to talk about, hey, this outlier, it's really going to change how you look at it. You need to go to those end users, because once you go to production with a model, if you haven't talked to them about what the outliers might look like, or to the point, just acknowledge that they're there, they're going to see a result and go, man, that doesn't make any sense, and they're going to lose trust in the model, right? So actively tell them, hey, some stuff's going to look weird. You need to tell me when it looks weird. Again, this is part of that feedback loop, right? When you see something that doesn't sit right, come and talk to me so we can figure out why it's not working. Or maybe it is working, and we're really changing the view that they have. Same thing about the data, where you have, especially models that cover like multiple portfolios, some of those portfolios you're going to have less data, and the results aren't going to be as credible. So very, very explicitly go to them and say, here's where the data is thin. You know what? This segment, the model's not as good. We didn't have as much training data. So this is one where you guys really need to use your judgment. And finally, so use visualizations only when they support the story effectively, right? Don't build visualizations for visualization's sake. They need to be intuitive. Simplicity is great. I'm sure that there are many Tufty disciples, but simplicity of design and complexity of data, it's a trade-off, right? How much data do I want to pack into it? These are a couple of examples, because simple can be bad, overly complex can be bad. Somewhere in that is an example, is in the middle. So this one on the left is one of my favorites. So I don't know if anybody's used Emblem. This was the most predictive element that we found as we were going through something. And when you look at it, everybody's like, this is really predictive. I look at that graph, and my first thing says, well, but I feel like the prediction is telling me it should be going this way, and what you're telling me is happening in the scoring is going this way. Those bottom bars are just exposure. It's just the quantity of the data that's underpinning it, right? It's just bucketing. So why is that there? The end user that I'm going to and saying this element is predictive doesn't care how much data is in each of those buckets. I know it's enough data to make those buckets credible. I can just tell them, hey, we expect that in this middle one, it's going to go down. And so, again, it's a simple one, but it just confuses people. This one on the right is probably the most data-dense visualization I've ever built. It required a slide prior to the slide that had this, so people understood how to read it. Not something I'd ever recommend doing. We also spent a ton of time trying to build it and pack all this information into one thing. OK, so a couple parting thoughts, and then hopefully time for some questions. So, it's 3 steps. Knowing that you're building analytics for humans is kind of step 0, I'll call it. But 3 steps to building the analytics. 1, build the right team. Build a team of people who are focused on building analytics for end users and have that communication. Secondly, build the analytics in collaboration, iterate with your end users, and finally, present the data in a way that the users can consume. Ask them how they'd like to see the data. Ask them how they typically consume the data. Next piece, the business user is there to interpret and use the model. They're not there to execute 100% blindly on the model. In insurance, the risk of people not evaluating what's going on is enormous. I don't want them to blindly follow what the model says, because guess what? Models break down in the tail. And models are just models, right? My next point. We know that models aren't perfect. They aren't. We have to express that to those end users. And finally, when we're doing these analytics as an input to the decision-making process, we have to develop them with the people that are going to use them to make the decisions. So I have a couple minutes left. Any questions?
I think we've got one over here.
You talked a bit about using some black box models in highly regulated industries, such as insurance.
Sure.
How you're figuring out?
So a lot of times it's really hard to do those depending on how the regulation works. Commercial insurance, so to be completely honest, commercial insurance is less regulated than personal lines insurance, and definitely doesn't have as much regulation as other aspects of the finance industry. If you are in an industry where the model is going to be regulated, this idea around iterating with the end user might have to include the regulators. You may actually need to bring them into the process to say, early on especially, if you're trying to move, especially if you're trying to move from GLMs or linear regressions or things that are fairly transparent into more of the black box models, it can actually be worth engaging with the regulators early on in the model development process to hopefully get the buy-in from them that this is sound, this is good, this is what we're going to do. The other piece you can do, if you can get the regulators on board with this, is do like crosstabs and post-model valuation so that you can still give them an indication of what the model's doing, even if you don't have that, if you're doing a neural net where you don't have that explicit input-output parameterization. If you do crosstabs or like, validations on the back end to say, here's the 10 things we're going to check, you can sometimes get them to work with you on that. The insurance is regulated state by state, so I work with 56 different regulation offices. So there is no one rule. That is unfortunately the case. But so it's a couple of techniques. It doesn't always work. There are models that we've tried to file that we actually ended up not being able to use because we couldn't get the regulators to work with us on them. And again, it's because for us it's a state by state consideration.
Okay, we got time for one more. Do we have any other questions? Anybody? All right, can we have a hand for our speaker?
Thank you.